So that is our question. A block of metal of mass 1.5 kilograms, which is suitably insulated, is heated from 30 degrees Celsius to 50 degrees Celsius in 8 minutes and 20 seconds by an electric heater coil rated 54 watts. Find part 1 of the question, the quantity of heat supplied by the heater. So this question is divided into 3 portions, we'll see. So first we want to calculate the quantity of heat that is supplied by the heater. And since we have the power rating of the heater and we know the time that it takes to supply that heat, then we can calculate the quantity of heat. So we know that quantity of heat will be given by power multiplied by time from the Joule's law. So power times time. So our power, we have been given in its SI unit as 54. Then we multiply by time in seconds. So here we have 8 minutes. We convert it into seconds by multiplying by 60. So our time will be 8 times 60. That's what we have. Then we have and 20 seconds. So here we add plus 20. That way. So we have 54 multiplied by the total there, which is 8 times 60, then plus 20. So we'll end up getting this as 54 multiplied by, this is 8 times 60, which is 480, plus 20, which is 500. So we end up getting our heat energy, or the quantity of heat supplied by the heater, as 54 multiplied by 500, which is 27,000. And this is heat, so it is in joules. So we have 27,000 joules. Is it clear? So we can move on to part B of the question. So we are told to find B. So part B, we are told to calculate the heat capacity of the block. Remember, the block is being heated using a heater. So a block of metal of mass 1.5 is suitably insulated and it is being heated. And here we are assuming that there is no heat loss. So we are told that it is suitably insulated. That is to minimize heat loss to the surrounding. So in this question, we assume that heat loss is negligible. So all the heat that is being supplied by the heater is being used to heat the metal block. So heat capacity of the block, we remember that heat capacity is given by the quantity of heat, in our case supplied, divided by the change in temperature. So our heat capacity, the heat that is being supplied, is 27,000 joules. And the change in temperature, it is being heated from 30 degrees Celsius to 50 degrees Celsius. So the change in temperature will be 50 minus 30. And these are Kelvin. So we are going to have 27,000 joules divided by 20 Kelvin. Divided by 20 Kelvin. So we end up getting our answer for that. That is 27,000. We are dividing by 20, which we get as 1,350. That is the heat capacity, and it is in joules per Kelvin. Remember, we have said that this change is in Kelvin, which is the SI unit, because even if we get it in degrees Celsius, it's still 20. If we convert it into Kelvin, you still get the same. So we say that it is 20 Kelvin. So when you divide this, you end up getting 1,350 1,350 joules per Kelvin. So finally, part C of the question. So we are told to find, part C, find the specific heat capacity of the block. So that is very easy now that we have the heat capacity, and we say that specific heat capacity is heat capacity per unit mass. So we have our specific heat capacity as heat capacity, which is 1350 joules per Kelvin, divided by the mass of the block in its SI unit, which we are given as 1.5 kilograms. So we just come and divide by 1.5 kilograms. So what do you end up getting as the specific heat capacity? You simply divide 1,350 by 1.5. So you end up getting that the specific heat capacity of the block is 900 joules per kilogram per Kelvin. So that's how we approach that question and many others that you can be given on specific heat capacity. So I'd like to leave you an exercise, 2 questions to attempt. So that's the exercise. Number 1, find the final temperature of water if a heater source rated 50 watts heats 100 grams water from 25 degrees Celsius in 5 minutes. We've been given the specific heat capacity of water as 4,200 joules per kilogram per Kelvin. Number 2, calculate the heat evolved when 100 grams of copper are cooled from 90 degrees Celsius to 10 degrees Celsius. And the specific heat capacity of copper is 390 joules per kilogram per Kelvin. So calculate and ensure that in your calculations you remember to express all the units in the SI units. So during our next lesson, we'll continue with the specific heat capacity, but in this case we'll advance more and be in a position to get more calculations or numerical problems on the specific heat capacity. So you can join me in our next lesson. Thank you.